Is it okay now?
Yes, sir. Your screen is visible, sir.
Yeah. Oh, many thanks to KL University and many thanks to Dr. S. Arun Mehta sir and students and the faculty of Department of Electronics and Communications in KL University. Many thanks for the introduction and many thanks for giving this opportunity to talk about EV technology. So I have chosen this topic and also given by Dr. S. Arun Mehta sir because it is related to renewable energy, smart grid systems also. So before entering into my topic like trends in EV technology, I would like to say about the history of the EV technology, that is electric vehicle. So electric vehicle was invented in 1880s. After 1880s up to 1902, EV was under development, and also it is used by many like and after 1902 to 1950 it was abandoned because of the lack of charging systems and lack of battery technology and those things. People are not interested. So in between 1902 to 1950, it was abandoned. And then again it takes a boom after 19, especially in after 2009, 2000 beginning. So EV took EV take a very huge span. And for example, Chevrolet, Tesla, and Nissan Leaf, those are all those leading manufacturers, motor manufacturers concentrated on EV, and they released their version. For example, Nissan Leaf released in 2009. So nowadays, each and most of them know about electric vehicle. They are interested in more electric vehicle because it has a lot of futures. Not only time saving, not only giving the it is the part of it is giving the major importance to reducing the emissions like global warming. So not only technical people, even non-technical people are also interested in EV technology. With this summary, I would like to enter into my this development program or this training. So first, I talk about the EV basics with respect to industry and as well as aerospace. How the EV electric vehicle change the car manufacturing, that is automotive industry with respect to air and also with respect to road. Maybe people know about the on roadways. And then I talk about the future trends. Why do we want to talk about future trends? Which I will compare. I want to say about what are the issues, and even in the past, and how it is solved, how it is solved, and how it has been solved by many professionals. And those things I will discuss. And and then next I will talk about the trends in EV technology. Now talking about the battery technology and also the regenerative capability, that is vehicle to grid and vehicle to home technology, and those stuffs I will talk about in the trends in EV technology. And this FDP is for especially for faculty and students. Because of this reason, I introduced the EV design. I collected the information from TVS, Tata Nano, and Toyota Hyras device. So I took the little. I will discuss about the EV design and case study. How the power rating of the motor, electric vehicle motor has been identified, how it has been calculated, and what are the power losses, and what is the charging system is required, and how long, whether it is a 10-minute charging or 30-minute charging or 6-hour charging, how it depends on those and all I discussed in EV design and case study. And then again I will talk about what are the opportunities, present opportunities. You can work it out. That means what research topics related to electric vehicle. Finally, I will conclude this FDP with your questions by answering to your questions um, and the remote discussion. Okay, let me move into the next one. This is the EV basics. EV basics means what? Electric vehicle. Electric vehicle consists of major three components. First one is power electronics. That is power electronics is with power converters and the motor controller. That means electric motor. That is the main component. And the second one is the battery. Battery technology. Battery technology means you people know about lead acid battery, lithium ion battery, but there are lot of combination nickel metal hydride, cadmium batteries, and vanadium. So even NASA is working on vanadium batteries. Because it is quick chargeable and less cost when compared to lithium ion. So these are the battery. The second component. Third one is the charging system. That how the people always worry about the range and the time. When you go to the petrol station, you will fill up your tank within 5 minutes, and then you can continue your travel. So this is what the fast world, always thinking to get the problem, to get the solution for the problem in quickly. That is what with a short duration. So that means if you reach petrol station, you can leave petrol station within few minutes. But in earlier day, but with respect to electric vehicle, that is not possible in earlier days. But you can do it in the home. Even 10 years before and 15 years before, people used to take 4 to 6 hours to charge their electric vehicle. But nowadays, you can charge your electric vehicle within 30 minutes, less than 30 minutes or 1 hour, less than 1 hour.
Excuse me, sir.
So this,
Sir, your presentation is not shared, sir. It is closed just now. Just now it's closed.
What happened?
You can share it once again, sir. Like
Okay. Now,
yes, sir. You can turn off your camera also. Like bandwidth is little bit slow, sir.
okay. So, so did you hear the EV history? So, shall I start again?
Yeah, up to this we have seen, sir.
Okay. So these are the major three components like electric motor and battery and charging system. In earlier days, charging the electric vehicle was the tedious job. Because of that reason only, it was abandoned. But nowadays, the technology has developed well with respect to power electronics. That means the conversion system, power conversion system, and with respect to battery technology. So now EV electric vehicle take a boom. The market is increased, multifold, more than 20 times, 40 times, 50 times higher than the earlier. The EV vehicle market is now led by China. China is leading in electric vehicle production. Okay, so with respect to electric vehicle, basic means you have to know the major three components. As I said, charger, battery, and electric motor. With electric motor, which is related to power electronics, converters, and drives. So there are other these are the terms which are related to electric vehicle. So, for example, energy source. Not energy here. The source for the electric vehicle is not only battery. So the another source is solar, so that I can talk about later. So that is the solar and battery. And then that why do we need battery charger? Battery charger means you have the ready-made electric power supply from the plug and play. So that is also there are three sources you can talk about. And then with respect to electric propulsion, there are The conventional is ICE, that is internal combustion engine vehicle, electric vehicle, and then another one is the hybrid electric vehicle, and the last one is the pure electric vehicle. So, but these electric propulsion is based on the power converter and the electric motor and the power controller to control the motor and the transmission between the electrical energy to the mechanical energy. So, these are the important terms you have to be keeping in your mind when you work with electric vehicle. So the acceleration means, so these terms are common to ordinary vehicles like it brakes and steering and acceleration supply. But the temperature control and energy management is specifically for electric. You have to do the
Sir, voice is not audible, sir.
Imayavaramban, sir? Sir? Sir, disconnected, sir. சார் நீங்க இது வீடியோ மட்டும் ஆஃப் பண்ணிருங்க சார். இன்னும் டேட்டா அதிகமா எடுக்கிற மாதிரி இருக்கு தெரிய போகுது. ஓகேங்க சார், ஓகேங்க சார். எஸ் சார். நோ ப்ராப்ளம். You're not joined, sir, actually. Yes, sir. Yes, sir. Yes, sir. Fine. Yes, sir. Visible, sir. Sir, while sharing screen, share entire screen, sir. If you are clicking, it's still in EV basics. Your screen is in still EV basics. Yeah, it's now changing. Now it is changing. Yes, sir. Click on presentation mode. Yes, sir. Just you minimize it, sir. Minimize that, it will come, sir. Yeah, you can minimize this, sir. No, sir. It will be in the app. It will be in the app. Just minimize this. Yes, sir. We can see that presentation, sir. Just yes, sir. Yes, sir. Fine, sir. Now it is fine.
Voice is not coming, sir.
Sir, unmute, sir.
Okay, is it okay?
Yeah, just change the slide, sir. We'll check once.
Ah,
Yes, sir. Next slide, sir.
ah,
Yeah, it's fine. Fine. Fine, sir.
okay, thank you. Thank you. So we have to think about the three major components. One is the electric motor, one is the battery, and the charger. So as I explained, there are one more source for electric vehicle, solar and 240 volt 58 system, that is plug and play. So these are the two sources. When we are working with sources, we have to think about the power quality, power and grid balancing. Because not only we are getting power from power from battery, so it also from solar, that is renewable energy. So that's why I put here energy management. Energy management with respect to battery management system and as well as the renewable energy. And temperature control I already explained. So temperature control, why do we need temperature management means when we are working with power conversion, so we are working with, we have to think about the power conversion, power converters, like AC to PCR, DC to AC, and these are the power conversion. For that we need switches. That switches creates the losses. Like there are raise time, fall time, conduction time. So these are created the switching losses plus conduction losses. So that losses increases means that will increase the temperature. So eventually the device will fail. So because of that reason, temperature control is very important. So energy management. So I want to introduce the electric vehicle concept with respect to aerospace. That is, here it is called more electric aircraft. More electric. Why it is called more electric aircraft means usually aircraft uses 4 powers like hydraulic power, pneumatic power, electric power, mechanical power. So these are the 4 powers used in the aircraft to take off, to land, and to fly by. So these are the actions done using these four powers. Why it is called more electric aircraft means all the powers except the electric power is like a pneumatic, hydraulic, and mechanical. These 3 powers are replaced by electric. That's why it is called an electric aircraft, more electric aircraft. I hope you understand. So now the Boeing 787 Dreamliner and the Airbus A380. So these 2 aircrafts are called more electric aircrafts because they are equivalent to the electric vehicle, but it is on the air. Electric vehicle, the car, 2-wheeler, 3-wheeler, 4-wheeler is on the road. That is the only difference. For this, I have done project in 2006 for Boeing. But this is the project I have done it for Boeing, and Airbus also I have done. That is called more electric aircraft and all electric aircraft. All electric aircraft means that there is the only power, electric power is used to take off, to land and fly. That is called all electric aircraft. More electric aircraft means there is some little hydraulic power and pneumatic power and mechanical power is still used to do the aircraft operation. So here, I use the power electronic converter to 3-phase fixed input and fixed supply is converted into variable voltage and variable frequency, so that you can get the drive. It's called adjustable speed drives. So here I use the AC induction motor and the regeneration control unit is the proposed system. So whenever the regeneration is detected, the novel regeneration control circuit is activated and the excessive power is dissipated. Because so aircraft power system stability is very important. Because of that reason, the excessive regenerative power must be dissipated in the system itself. So that's why it is called more electric aircraft. This project is called avoiding regeneration with a matrix converter drive for more electric aircraft. This is a project, the large project supported by the Smith Aerospace and also Boeing 787 Dreamliner. So this is the laboratory I used in University of Nottingham when I was in UK. So, and this is the hardware, and this is the FPGA development for to control the aircraft power systems. Okay, so I just want to introduce you. The electric vehicle concept is introduced in the aerospace even in 1800, before 1800, but it was slowly adopted, like electric vehicle. So, and I get back to our FDP program, that is transition EV technology. So EV basics, this is the EV basics. As I said, there are three main components. One is the electric motor, another one is the source, battery, and the third one is the charger. So here you can see. So this is called charger. So here see plug and play electric vehicle. So charging, and then this is the source battery, and this is the load. BLDC motor is used to drive the electric vehicle. As I said before, when we are working with electric motor, we have to think about the controller. That is the power electronics controller, and also when you are working with charging system, you have to think about the charger controller. Hello?
Yes, sir. Yes, sir. Your voice is audible, sir.
Okay. So why my screen is not changing?
Sir, you can look onto the sir. Sir, you can see on the PPT alone, sir. I think you are used to two devices, right?
Two devices. Is this one?
1 minute.
Okay. So shall I close and get it back again?
Yes, sir. Yes, sir. Yes, sir. Like you have connected in the two, sir, in a browser and app. That's why. That's why the because of that one only the lagging. Yes, sir. Slides are fine. Now you can unmute, sir. In the top, sir. At the top. Top, sir.
Okay.
Yeah.
Okay.
Yes.
Shall
Yes.
I continue?
Fine. Yes, sir. Yes, sir. Go ahead, sir. Go ahead. Go ahead.
Yeah. Now, as we think, as I said, so BLDC controller, we have to think about the power electronic controller for motor, and also the power electronic controller for battery charger. So these are the major parts related with the power electronic device, power electronics and drives. And here you can see the throttle control. So this EV basic structure is for two-wheeler system, and it is also applicable for four-wheeler system. Instead of throttle, you will get the steering system. And here you are getting forward and reverse. That means what? Forward means you will get the watering action, and reverse means you will get the regenerative action. That means you people might hear about vehicle to grid and vehicle to house. So that means what? Reverse. That is the regeneration. if the excessive power is generated in the vehicle, that would be transferred to the grid. And then we have to think about the power quality and grid balancing. And these two things I will talk about later. And so this is the EV basic structure. And let me move next step. So this is the major types of electric vehicles. So conventional internal combustion engine. This is the conventional. That means normally not now we are using. Everyone knows about that one. So next one is the hybrid electric vehicle. Hybrid electric vehicle is the combination of the better features from conventional and as well as the proposed system. The proposed that means electric vehicle. Here, hybrid means the two types of sources we are using here. One is the battery, and another one is the fuel. The chemical energy is converted into kinetic energy, and also the electrical energy is converted into kinetic energy. So here, that's why it is called hybrid. Two types of sources: fuel and battery. For fuel, we need engine that converts the chemical energy into kinetic energy and helps to reach our destination using the vehicle. So, and battery is here the electrical energy is stored in the form chemical form, and that it delivers electrical energy. That electrical energy is put into the motor, electric motor. That motor gives the mechanical output. So that's why it is called a hybrid. That is two types of sources. In Gulf nations and most of the Middle East nations like hybrid electric vehicles, because they want to travel long. As I said in the introduction, electric vehicle has two potential problems. One is the range, that is the mile range. Can you able to travel 100 miles, 1,000 miles, or 2,000 miles with this electric vehicle? That is the question mark. 1,000 miles means what? Approximately 1,600 kilometers. Is it possible? But Tesla Y model says they can travel use the Tesla Y model up to 1,000 miles, but there is a still question mark. So that is with respect to electric vehicle, pure electric. This is a major problem. And the second is the charging. So can you able to charge your electric vehicle for 1,000 miles destination within half an hour or within 6 hours? So these are the two obstacles, and still people are facing and trying to work out range and the charging system. So the third one is the that's why Middle East nations like hybrid for half that is battery plus fuel. That is convenient for them. They can reach anywhere, even more than 1,000 miles. They can reach that destination. But the Europe and the North America, the people are wanted to achieve the performance of hybrid by only pure electric vehicle. That is the battery electric vehicle, battery EV electric vehicle. That means for battery and generator and transmission, simple system. But this is facing problems. This type of electric vehicle has potential problems, as I said, charging system and range. So they are working now, and the ongoing research is related to the range and the charging system. So this is the common types of the electric vehicle systems. Now, so what is the difference? Major difference? How the electric vehicle attracted so much market? We can't say within the short duration. It has been, as I said in the introduction, electric vehicle was invented in 1880s, and after it was abandoned between 1902 to 1950. So how? Because of the efficiency. The electric vehicle is capable to give 50% efficiency, but you cannot get that much efficiency in internal combustion engine. But you can go with long, long range and quick fueling systems, and those things are you can get in internal combustion engine. The same future will be get in the electric vehicle. That's why ongoing research about electric vehicle deals with the range and the charging system. Here you can see the internal combustion engine. So pure internal combustion engine vehicle, it can capable to give only 17% of efficiencies. You know how much losses are happening here. Nearly we are losing 83% of efficiency we are losing. But after you see micro hybrid electric vehicle and then medium electric hybrid electric vehicle, you see slowly the efficiency of the electrical vehicle system is increasing. When it comes here, full hybrid electric vehicle, you can get 50% efficiency. That means what? 25% of 20% efficient, 25% efficiency when compared to the internal combustion engine. When you see the plug and play, both are the same. When you get the pure electric vehicle, you can realize, can enjoy the 50% efficiency of the total cost invested in the fuel. Fuel here means the battery or solar system. So the electric vehicle efficiency is how many times greater than approximately multifold, 3 times greater than the internal combustion engine. You can see here. So this is the internal combustion engine efficiency, 17%. After that, this is called electric vehicle. So you can get up to 50% efficiency in electric vehicle systems. For that, you have to think about only pure systems. You should not think about the hybrid. Hybrid, as I explained before, hybrid means fuel plus battery. But pure EV means you have to think only about battery. So it has two obstacles, as I said. One is the charge with the charging system and with the range. The range means what? How much distance you can travel using the electric vehicle. So, but even the efficiency is 50%, but still it has the problem with these two factors. Okay. Now I talk about the EV future trends. As I said before, here you can see the electric vehicle means only three major components: one charger and battery management system, and power. So, but here I said only one source. You see, electrical supply 240 volt or 230 volt or 58 system or 68 system, battery and but one more source is introduced here. This is here the solar. So that's why the renewable energy is introduced here. When you think about renewable energy penetration, you have to think about the balancing the power. You know, the synchronizing the power is very important. Earlier only one source, so you know one source, like here battery, only one source. So you don't need to think about the balancing of power and storing of the power, because you cannot have a power for high power battery storage, energy storage system, ESS. Here we have to think about energy storage system, huge energy storage system, and also the high voltage cable, and also you have to think about electric motor, high power electric motor. And for that, if you want to control the electric motor, you need to think about the power lines converters, and for that we have to think about the temperature management. In order to maintain balanced supply to the electric motor, we have to think about the battery management system. And so these are the present trends, of the present trends of EV electric vehicle. The people are still working out how to solve the problems created by the power electronics converters or the electric motor or the battery storage systems. Okay, so here battery. Now people always talk about lithium ion batteries, and lead acid batteries. Nowadays lead acid batteries are not recommended because people now know the knowledge about the battery technologies. Because the researching the lead acid battery is difficult when compared to lithium ion batteries, and also even the cost is less. It cannot handle high power density, but the lithium ion it can handle high power density. So that's why the battery packs, we have to think about the battery packs. and also you have to think about the range, how much range per cycle it can go. For example, if you charge at one cycle, can it go for 100 kilometers, 500 kilometers or 1000 kilometers, like that? We have to think about the battery cycle, life cycle. How many cycles it can come, either 250 cycles or 2500 cycles. So these are the trends about the EV technology is currently undergoing. So as I said, the issues found. So and with respect to the charger, so we have to think about the plug and charger. Why we work out, why we think about plug and charger. So the AC charging system is slow when compared to DC charging system. So here we have to think about when you are working with DC charging system, you don't need to think about too much control of the charger. Because this is DC and also DC charging system. But when you work with AC, you have to think about the power conversion before reaching into the battery, storing into power stored into the battery. So here the problem is one is the battery management system, how to manage energy management control, and the third one is the thermal management. So these are the issues. These are the major issues with respect to battery charger. See, but after the battery, the energy is stored in the battery, then it is delivered to the wheels. That is what transmission, mechanical transmission. In between, it has to be it has to be converted into the reliable power supply for the electric motor. So for that you need DC is converted into DC. That is the flexible DC is converted into fixed DC, and then again the fixed DC is converted into variable AC and variable frequency supply. So then only you can get here the speed adjustable speed drive. That means not variable speed. You can control. You can stop, halt, or slow, or race, or quick race, and those things are all you can get but from the inverter operation. So here in the green, electrical transmission is given in green. These are the electrical transmission, and the mechanical is in the so not only the charger is depends on the power electronic converter, motor controller also depends on the power electronics converters. So that's why when we talk about the battery, you no need to think about the slot, but you have to think about the maintenance and also how to maintenance under the battery management system. That is the major obstacle when compared to battery. And then DC to DC converter and DC to AC converter, we have to think about, as I said, when we use switches, we have to on time, off time, raise time, fall time, delay time. So these are the operations can create, the delay time and raise time and fall time. These are called switching losses. And then the conduction time will create the conduction losses. So we have to deal with this switching losses and conduction. If you don't bother about switching losses and conduction losses, it will increases the system temperature. That means when the system temperature increases, the system will eventually fail. So we have to think about how to solve how to reduce the switching losses and the conduction losses. And the third one is the motor control. Motor controller. Motor means electrical energy is converted into mechanical energy. Here the three types of motor. You can use induction motor, you can use permanent magnet synchronous motor, or BLDC motor. So permanent magnet synchronous motor and BLDC motor is more or similar. You can control easily when compared to induction motor, because induction motor is sluggish performance. You cannot control easily unless otherwise you adopt the field oriented control, FOC, because in the induction motor is in the field, and the armature current is not perpendicular. That means what you cannot get 100% efficiency from the induction motor unless otherwise you apply the field oriented control. That means the armature current and field current must be quadrature. Then only you can decouple the systems. Then you can get the high efficiency and high torque performance, high speed torque performance. But when compared to thermodynamic synchronous machine and BLDC motor, they are naturally and similar to the DC motor. That is armature flux and field flux is perpendicular, so you can control easily the quadrature current and the D-axis current. If you call, that means that is called vector coupling. Decoupling the quadrature current and the D-axis current. That means we are controlling the motor efficiently. So we have to think about that thing also. What type of motor are you going to use? Are you going to use BLDC motor or conventional motor or induction motor? So these are this is the also issue. And here with respect to mechanical transmission, we have to think about the suspension. We have to think about the bumper and those things, but that is not related with only electric vehicle. It is solved already. So here, what are the research? What is the present trends and the research topics and some research scholars supposed to be work. If they want to work on electric vehicles, they can think about vehicle to grid. How to, because when you are moving the forward direction, so it is only water injection. But when you do the reverse or when you do the braking, so the motor is automatically turned into a generator. That means what? So your load becomes a source. That means it can send the power feedback to the source. That means it should not affect the existing power supply. So it should be transmitted to somewhere safely. That's why vehicle to grid. The excessive power is synchronized with the grid. Whenever the vehicle transmits excessive generate the excessive power, that excessive power transmitted to the grid. So we are here, the research topics are how to balance the grid balance when the vehicle is regenerative power. So that is the present and future research. Even this research has been started, my knowledge, with respect to my knowledge, the vehicle to grid research has started in 2010. Vehicle to grid. Even before also, I do not know. But first IEEE transaction paper I read about vehicle to grid is, in 2010. So that is even still it is a problem. People are not yet solved. And also one more thing, the wireless power transfer. Wireless power transfer means what? Without any physical connection, you have to charge the electric vehicle. That means, now people are thinking about on the go. While traveling from source to destination, you have to charge the electric vehicle. That is the present trend. Wireless power transfer means, on the go, not in stop and charge the electric vehicle. No. So now the present trend is on the go. How to charge the electric vehicle on the go, and then the overhead power supply. So you people know, you have seen our electric trains in India. So like that, they are thinking about the overhead power supply. So these three, the vehicle to grid and on the go wireless power transfer and overhead power supply. So these three are giving the research work for the research scholars. And even still, these topics are not comfortably and reliably giving the expected results. So these are the ongoing research topics. Vehicle to grid and the on the go wireless power transfer and overhead power supply. And here the battery, the next one is the battery charging. As I said, even the 10 years before, if you want to charge the electric vehicle, you have to suppose you to wait more than an hour, up to 6 hours. So that the electric vehicle users are used to charge their vehicle during the sleep, during the night. But nowadays, you can charge the electric vehicles within an hour, less than an hour. You can, for one cycle, you can go up to 500 kilometers. Even the Tesla models are started to give more than 500 kilometers. Up to you can go 1,500 kilometers for one cycle charge. So here these are developed battery charging technology, but still people are working out. And here battery technologies means this is related to like what type of battery are you going to use? That is what this. So are you going to use only lithium-ion battery, or are you going to use only vanadium regulated, water regulated battery, or are you going to use only the nickel cadmium battery, or going to use super capacitor as a battery? So these are the technologies. But these two are already reached nearly. But other three are giving the opportunities to do more research on their topics. Like even the still some people are talking about the better technology. What they want to do combination of like when you come lead acid battery when compared to lithium ion battery, lithium ion has high energy density. But lead acid has the high power density. So when you combine together, you have to get high power density, high energy density. These kind of thinkings are going around under researchers. So that's why I put the electric vehicle future trends and research. So people can those who are interested to do PhD, so they can work on vehicle to grid and on the wireless power transfer and overhead power supply. So even if you think about you can work out the battery technology. Okay, so now, so this is trends in EV technology. As I said, battery, yes, battery is very important here. The battery systems, we have to think about the battery technology. Whether are you going to use, super capacitor or vanadium related battery or combination lithium ion or lead acid battery. So they still it is not reach the reliable and comfortable as result. And here the battery solutions. That is battery solutions means it is related to battery management system. You cannot get battery as a single cell. So you have to do battery package, battery pack. Battery pack means it consists of many battery cells connected in parallel connection and series connection with respect to the your rating, your rating. That is the motor rating. Because electric motor is driven by that. So that you have to think about battery management system. Each and every cell has to be connected. The voltage across each cell must be equal. Otherwise, if imbalance occurs, that can reduce the lifetime of the battery and those things and all. So you have to think about the battery management system. And the next one is the power electron. Yes, the power electron is converter nowadays well developed. Earlier days, earlier days, there is no silicon carbide switches. Nowadays, our silicon carbide MOSFET switches are available. So people are happy with that invention. When compared to silicon IGBT, the silicon carbide MOSFETs are very good and applicable, and they can tolerate high temperature when compared to silicon. If suppose silicon can tolerate 100 degrees Celsius or 125 degrees Celsius, it means silicon carbide can tolerate up to 3 times, more than 3 times, 300 degrees Celsius. That means you can work out thermal management easily nowadays. And the charging system, as I said, you have to think about the charging. How long uh, to charge? So we can't wait for 1 hour, 6 hours. We have to finish within 10 minutes or within 20 minutes or within 5 minutes. So that's why you have to think about the charging system. Charging your but this charging is depends on the rating of the electric motor, and as well as the range of the electric vehicle. So that because that deals with the power. And then the traction system and hybrids. Yeah, traction system here, as I said, traction system. So motor, electric motor. This is the traction system. And what type of motor are you going to use? Are you going to use BLDC motor or permanent synchronous motor? These are both are similar, or induction motor. So that is why traction system or hybrid you want to change. So and telematics means it is a communication system like IoT, Internet of Things. You have to work out the Internet of Things. You have to apply your electric global positioning system. Where is That if you set the source to destination means the people can easily identify where are you at the moment. Those things are related with communication, telematics, Internet of Things. Not only Internet of Things, not only related with the travel, it also related with identify the battery management, and also charging system, how much charge is there. You can communicate and it will inform, and then you can control the to the EV, control and send the order to the EV, and those things. And thermal management is very, very important. As I said, so SiC can tolerate it. Silicon carbide switches can tolerate high temperature. That makes easy for thermal management. Thermal management is easy. And as I said, battery management, you have to think about the across each cell is equal, and it must be whether it is tightly coupled or not. Those things and all you have to think about battery management system. And EV testing, yes, before it comes into the reality, so it has to be tested in the current and the input voltage systems, and what is the kinetic energy, and what is the range, and what is the maximum power applied, and what is the maximum power delivered. That means what? Electrical power delivered is a mechanical power, and what is the efficiency of the system, EV system, and those things we have to think. And grid balancing, as I said here, so this is the grid balancing, vehicle to grid. So when it is in forward motion, you don't need to think about when you are doing electrical brake, that's not braking and reverse, and we have to think about the excessive power. Excessive power should be connected to the that is transferred to the grid, so that you are selling the electric power to the government. That means you can get revenue. So if you work out this grid balancing, if anything is not synchronized, for example, grid balancing means what? Synchronizing the voltage and synchronizing the frequency. So these are two major important phase. So these are very important when you are think about grid balancing and power quality. I hope you people understand the terms, what I said. Voltage synchronization and frequency synchronization and the phase synchronization. This is very, very important. When the car electric vehicle is generating the power, and if you are transferring to the grid, that means you have the voltage synchronization and the frequency synchronization and phase synchronization. Otherwise, you are in the problem. So that is why that is called grid balancing. So these are the
unknown number la call பண்ண சொன்னா பார்த்தா.
Hello?
சேவ் பண்ணி வச்சிருங்க.
Hello?
Sir, sorry sir. Go ahead sir.
Okay. Then, so trends in EV technology, the research, nowadays research is going on electric vehicle technology. What are the research? The multi-phase electric motors. So here you can see, single phase motors. So single phase. This is also single phase. Here, all those conventional system, conventional hybrid, and conventional electric motors are discussed with the single phase systems. Single phase system or three-phase system. That's it. But here people are doing the research on multi-phase. That means what? 6-phase systems, more than 3-phase systems. So that is going on. And efficient power converters. Yes. So they are now thinking to switch over from silicon to silicon carbide to get high efficiency, high thermal management, and less switching losses. These are this is the second efficient power converters. And the smart control systems. Yes, as I said, so IoT, Internet of Things, and also I said on-the-go wireless power transfer and adaptive control system, and also the artificial intelligence. These smart control systems these are the ongoing research in EV technology. So you have to think about artificial intelligence, Internet of Things, and wireless communication, not only for the communication signals or getting the control of or the status of the electric vehicle. It also we have to think about the charging, wireless charging, and those things, and adaptive control. That means what? Autonomous vehicles. So you have to drive the electric vehicle, just to put the destination, that the vehicle will reach the destination. That is called adaptive, the automatic vehicle. For that, you have to think about the adaptive control systems. And then next one is the electric flying cars. You people heard about my air taxi, So the Empire and Lilium and Airbus, Boeing. These are the leading airframe manufacturers are working out the air taxi. Here, but this one is electric flying cars. So this is like a car, but it can fly, not equal to not at so much height like electric aircraft. It is just above the ground. And the NASA now working on space electric vehicle. It uses it is working on space electric vehicle, and it will be used in the space to not travel around and to note what are the things going around in the Mars or something in the space. So that's why they are working on the space electric vehicle. And next, so this is the transition electric vehicle and research. As I said, a traction system. So the vehicle to grid. So this is the traction system and grid. So traction system and high voltage management. So nowadays, they have for up to 400 miles range and 500 miles range only. But that is also not reliable till date. It is going. So we have to think about how to manage high voltage management, so that we can put high rating motor. For example, 400 HP motor, so that it can cover 1,200 miles. That means what? 1,800 kilometers, like that. So you have to think about the cable, high voltage cable. So here you can see. This is the high voltage cable. How to manage the high voltage cable? So that is called high voltage management. And the energy storage. I explained energy storage system about battery. So this is also ongoing research. Thermal management also I explained, and charging system also. So this is you can concentrate on these systems. Electric traction system means motors, electric motors, and high voltage means the cable systems and arrangement, and the heat sinking, heat tolerance, and those things are cables related to high management system. This is now we are working on light vehicle. So these are the bus and trucks or heavy vehicle systems. We have to think about this. So these are the our ongoing research about the EV technology. Okay, so what is the innovation? Is the innovation required in EV electric vehicle motor? So innovation, as I said before, here I said multi-phase electric motors. So that is what going on. Multi-phase. Why do we need multi-phase? Because current density per phase. If current density per phase is high, means so it can cause the heat. Then eventually the cable will fail. But if you use multi-phase system, the high current density per phase is reduced, but the same power rating is achieved because of multiple phase. For example, 6-phase systems. If you use the high current density 3-phase, when compared to high current density for 6-phase, so which is stable, the 6-phase system is, because the current density is shared, so that harmonics is reduced. Harmonics is reduced means the current losses is reduced. Losses reduced means the heating is less, so that cable can carry a long lifetime. And also, high torque power density is achieved. Even in addition, if one phase is failed, it doesn't matter. The everything can continue its operation with the remaining phases. These are the advantages of multi-phase electric motors. Multi-phase electric motors. Here I put just a simple 6-phase system. Okay, so here people know about this curve. So this is nothing but a torque speed curve. So here up to this base speed, it is called constant torque region. Here the power is varying. Once it reaches the base speed, then the constant power region resumes, and the torque is reduced. Okay, that is this area is called field weakening mode, and this is called this is the recovered operating area. So, but for electric vehicle, people are on the Texas Instruments and the other, Nissan Leaf and Chevrolet and Honda these leading automotive manufacturers are thinking about just the V/F control and V/F control with field weakening mode. Because you need to think about linear motion and drag motion and lift motion and rolling motion when you work with four-wheeler, four-wheeler electric vehicle. So these are the dimensions is required in electric motor drives. So that is called light materials because the weight is more important. Even with respect to car or with respect to aerospace, weight is very important. That's why when you go to air, when you do air travel, your luggage is more serious concern because if you take 48 kgs allowed, if you take 49 kgs, you will be penalized high because of this reason only. Yeah, weight is more important when. So lighter material in motor construction is ongoing, and the alternative solutions. So because I said permanent magnet motors and BLDC motors, these are the rotor is a permanent magnet. So we have to think about the alternative for the rare magnets. And the overall performance characteristics. This is the overall performance characteristics. The torque versus speed. The speed is related to the frequency and torque is related to the power. Because the torque producing current is directly proportional to the output power. So here when you work with V/F control, so that means what? Because of stator losses, the motor will not start. So that means not self start. You have to apply the boost voltage, then the motor will start. So that's why this curve is very important. So you have to keep it in mind. So when you do the innovative work or creative work with the motor drives to increase the efficiency of the motor or the reducing efficiency increases means automatically the losses are decreases. So this curve is very important. So here this is the constant power torque region. This is the constant power. Nowadays, electric vehicles require this area to get raised. If you want you 150 or 150 newton meter or for example 4 water can produce 14 newton meter means you have to think about multiple types of the torque in this region, that is field region. But it will deteriorate the machine life. Okay, now the EV motor, electric motor price control. This is the simple speed control of BLDC motor. Assume you are using BLDC motor here in the electric vehicle. Okay, so the electric vehicle you see. So say you just sense the speed of the vehicle and that how to sense the speed of the vehicle. You have to use the all sensors. From the all sensors, you have to use the three. You are positioning where you have to find the rotor angle. That rotor angle and then find the error PA controller and then call it the PW and it will trigger the switches of the inverter. That output of the inverter goes to the BLDC motor. The BLDC motor reaches our destination. And here the BLDC motor, how to control the BLDC motor? Not you should not use off switching. Off switching means what? On and off. Here we have to think about soft switching. Soft switching means what? You have to use zero voltage switching or zero current switching. So because here BLDC motor has the exact characteristics, very good characteristics, so that you can apply ZBS here. So when the voltage across that EMF means what? Electromagnetic force, the voltage, output voltage goes zero, then you can switch on. That means what? Here switching losses are zero, reduced when compared to odd switching. This is called odd switching. Here this is odd switching, but he is zero. Here also you can do ZBS and ZCS, but it is very difficult. Here you see there are huge. This is the current, and this is the voltage. I will show the before simulation results. I will explain the FOC. So if you assume this is the induction motor, as I said before, as I said in the introduction, the induction motors are sluggish performance. You cannot be able to, but high efficiency motor, sluggish torque. So in order to get the high torque, from induction motor, you have to apply the field oriented vector control. FOC, field oriented control. That is field oriented vector control. That means what? You have to decouple the armature flux and the field flux. So for that you have to send the armature current, that is, and then it will be converted into the three-phase system into alpha beta. That is a stationary field, and using the Clark transformation, and then alpha beta is converted into dp transformation. That is the rotating form. So for that you have to calculate the theta. How will you calculate the theta? That is, this is called rotor angle. How will you find the rotor angle? So for that you have to apply, all sensors. You have to use all sensors and find the rotor position. Using this, you can calculate the rotor position. That is called theta. This theta is used to do the stationary frame into rotating frame. And again, inverse transformation. The rotating frame is converted into stationary frame. Here you have to put the ISP reference, and the actual is given that the error is processed through the PI controller and the reference. Here, then it will give the gate pulses to the three-phase motor. So this is the simulation, BLDC motor simulation. Here, I did this last year. I did BLDC motor for Australian company. I did this project. BLDC, two stator, two rotor, dual controller. And also this is available everywhere. This system. But this one is novelty. BLDC motor with controller 1 and BLDC motor with controller 2. I control the two stator, two rotor system. But this is research. Okay, so this is how as I said, how to calculate the theta, the rotor angle, using the all sensors. So here is the all sensors. This is the all sensor. All sensor A phase, all sensor B phase, and all sensor A phase, B phase, and all sensor. This means it not negative, not gate. So from that you have to calculate the position of the rotor. Once you know the position, then you can get the rotating frame and stationary frame with respect to here. If you park tension means you can get the rotating, and inverse means you can get the stationary frame. That again, the stationary frame converted into VAB and VBC, that is line to line voltage. From that line to line voltage, you can derive the phase voltages. From the phase voltages, you can calculate the gate process. So that is what this. And this is the output current, phase current of BLDC motor. What I used electric vehicle, that is two phase, two stator and two rotor controller. I placed here this result, one system result. I didn't give the cumulative result here because this is for just to know, aware of how the simulation works. See here, top sawtooth waveform. Here I explained the sawtooth waveform. You understand? The same thing here I have made, and also I explained here the soft switching is you can apply easily. That is the even Texas Instrument has the standard big component of the DSP system for this electric wheel. Sorry. So here you can apply ZVs. So your switching losses is less. Less means what? Almost zero. Almost zero. So efficiency of the system is increased. So this is the speed, 3000 RPM of the system. Okay. Now the comparison of electric vehicle motor drives. Okay, which motor is best for LV? So people are now using the BLDC motor. Induction motor is best. Then you have to apply the what? You have to apply the vector control theory. So when you apply vector control theory with respect to induction motor and the BLDC motor, this is little bit difficult when compared to BLDC motor is because here you can get the sawtooth waveform with respect to current. That means you have enough space to do the ZBS. But here in induction motor is sinusoidal. Sinusoidal frame like this. You cannot apply ZBS easily. Unless otherwise you have to calculate the zero positioning system from the back EMF A, back EMF B, C, back EMF C, three phases. Here is very easy in BLDC motor. But induction motor is 95%, greater than 95% efficiency. Nowadays, people are also getting here in BLDC also. Here you see power density is compared, and efficiency of the system is compared, and the efficiency is less. As I said, you see, induction motor efficiency is less when compared to BLDC motor and power. So permanent magnet synchronous motor and BLDC motor is similar, both are same. So, but induction motor and BLDC motor is not similar characters. Here you see the DC motor. So always we are trying to get the AC motor resemblance of DC motors. That is DC separately excited motor. Because the field flux and the armature flux is perpendicular. That means you can easily control the motor. Because of that reason only, all the AC motor is controlled like a separately DC. Okay. And now that runs EV technology with respect to power electronics. As I said, here you can see the graph. So here, this is voltage and the blue color is current. When the switch is on, what does it mean? When the switch is on means the voltage across the switch is 0. You know, the voltage across the switch is 0. Here you see 0 voltage on, and the current is I. That is the maximum current. So here they cross each other. You see here, crossing here. That means there is some voltage, some current. That means what? High power. These are the power losses. So this is hot switching. So in 0 voltage switching, here I explained. Here, when you do here switching, here voltage is 0. When you turn on switch here, the current will build up here. That means voltage 0 and the current is building up. That means what? Power means what? Switching losses means power. That voltage 0 into current anywhere, that is equal to 0 power loss. But here, in this case, not like that. You will get the voltage some value and the current some value. So power loss is switching loss is high. Switching loss is high means you have to think about the thermal management. That means what? Heat sinks or how to cool the system. So that we have to think about. So and also in the conduction system, that means system is conducting. That means what? So here current and less, here steady state loss. When the switch is off means what? The voltage across the switch is equal to the supply voltage. So this is the supply. But voltage open, switch is open means current is 0. You see 0. And this. And one more thing, if you use IGBT, you have to think about the tail current. But when you use MOSFET, you don't need to think about the tail current at all. That's why the IGBT gives the problem with the tail current. That means what? Additional losses. But when compared to MOSFET, IGBT has high efficiency. You cannot say high efficiency because what type of power rating are you going to use? If you use medium power, I would or low power, I would recommend go with MOSFET. If low power, if you use medium power and high power, please go with IGBT. So nowadays electric vehicles are using low power and medium power. So we can go with so the silicon switches are giving too much switching losses when compared to silicon carbide. So and also it cannot suitable for wide temperature range. So that's why people are moving from IGBT to silicon carbide MOSFET. That is the present research, research applied on EV electric vehicle development. Higher efficiency, yes, higher efficiency losses is reduced, and the power control losses unit is 20% of the total loss high, and the thermal feasibility of downsize, yes, thermal feasibility is very, very important. That depends on how you are switching and also how you are managing the switching losses. And improve the trade-off relation between the switching loss and steady state loss. Yes, I already explained IGBT. So with respect to the hot switching and soft switching. So my recommendation is go with the SIC switches, MOSFET switches, and do the choose the BLDC motor or permanent synchronous motor with soft switching. So that is the best solution for electric vehicle. Okay. Now this is the Toyota Prius inverter. So they are using here the battery. The DC battery, the one supply. It is converted into the DC into again DC. Why? Because you can get here 12 volt system or 24 volt system or 48 volt, depending upon whether are you going to use 2-wheeler system or 3-wheeler or 4-wheeler. So okay, so this is called boost converter. That's why here I put DC to DC. They put DC to DC converter. So when this switch is closed, the inductor is boosting up and storing the energy. And when this switch is off, this diode, the power is delivered through this diode through the DC link capacitor, and then this DC is converted into AC for it is fed to the electric motor. And one is for motor, one is for generator. This is the Toyota Pyrus inverter systems. No, and when you see this graph, what. So the first generation and second generation, third generation, fourth. Why did they put four? See here, the size is reduced. The size is reduced. Why? Because we got high switching devices like silicon carbide devices, and also the space is very less when compared to silicon switches. When you see the silicon switch IGBT that much bigger than the SIC MOSFET switch, the same rating. So that's why now in this generation the size of the control system is reduced, and also the power losses is reduced, and breakdown voltage is increased. So this is the graph. This is the confidential one. So these are the inverter systems they used. But this is the skeleton of the Toyota Prius inverter system. Here, next, as I said before, now silicon carbide MOSFETs are used for electric vehicles. So, because they eliminate the tail currents during switching. Here I said, so IGBT, when you use IGBT, you have to think about the tail current problem. So it can create the additional losses. But when you work with MOSFET, you no need to think about tail current. That is the reason the silicon carbide MOSFETs have been chosen. And faster operation and reduce the switching loss. I explained here. This is the hot switching, so it will increase the switching losses when compared to silicon switches. So you go with zero voltage switching or zero current switching. Okay. And then the maximum drain to source voltage. These are the parameters we have to think, because drain to source must be 2 ohm resistance or 5, so less than that one, because this resistance create losses. So that's why we have to think about these are the characteristics of silicon carbide MOSFET, and also maximum DC drain current voltage and the gate threshold gate charge maker. Here you see this is IGBT characteristics, and this is the silicon carbide. So temperature control when the same amp rating and the same. So think about the temperature of the IGBT switches here 100 degrees Celsius. The same silicon carbide has been with 70 degrees. That means what? So the thermal management design for SIC is easy when compared to IGBT system. Here also you see efficiency, the switching efficiency. So here the silicon carbide MOSFET always lies between 98 to 99, that is 100%. But here MOSFET this starts from 92 and variable up to 90, 95 system, 96 only. So silicon carbide MOSFETs are preferred. And okay, now I move into the next step, how to design EV. So when you are electricity parameters, you have to know about the voltage, current, power, and energy. So the unit is volt, amps. Energy means watt hour, power means watt. And mechanical terms are related to force, that is mass, velocity, time and distance and torque. So okay, now we have to think about inverter system design. So if suppose 10 kilowatt motor means how much you have to think about the inverter system for that 10 kilowatt motor, because then only you will get the variable adjustable speed drives. You can stop, halt, or raise, or control the speed of the motor. For that, that is the reason. Here you see. So if you have 10, you have to think about 15 kilowatt inverter for that system, because efficiency. People can say I can get 95% efficiency from my inverter. No, that is not possible in practical case. You can get approximately greater than 80% and less than 85%. So if you can choose a 10 kilowatt hour inverter for kilowatt electric motor, and so the if you get if 80% efficiency means that is 12.5 12.3 kilowatt hour, and conversion loss. So this is the initial conversion loss 0.8 kilowatt hour, motor loss point. So totally if you calculate it will come 1.7 kilowatt hour. So this is the system, and for this is for two wheeler. If you want to two wheeler, assuming that TVS XL or any Bajaj any so 1 kilowatt. How do you know? So if you want to move 100 kg with the speed of 50 kilometer hour, how much power do you need? That is what I calculated here. You see, the mass equal to weight of the vehicle plus driver weight. You know, weight of the vehicle is 50, and assume the driver weight is 100 kg. So if you want to move 100 kg with the velocity of 50 kilometer per hour, how much power is required? That is called electric motor, electric vehicle. This is for two wheeler system. For example, velocity you have to convert the kilometer hour per velocity meter per second. So power is nothing but the force into velocity. So that is here this is called velocity. So 1 by 2 mv square into t. So here 100 kilogram weight mass, and velocity is here calculated. 50 kilometer means 1000 divided by hour means 60 into 60, that is called hour, 60 seconds. So you need how much watt you need? 1 kilowatt. So 1 kilowatt for one cycle, you can move 100 kg for 50 kilometer distance. 50 kilometer per hour. 50 kilometer per hour. So this is the design for two wheeler. If you have any doubt, you can contact me anytime. I can give you. So and also how to find the current rating. So you know the power 1 kilowatt, and also you have to know the DC system. No, you have to think about 24 volt system or 48 volt system, depending upon the rating you want. So on safety factor, you have to choose always one. So for this is so current. This is like a Ohm's law directly. P equal to PI. So you know power, you know voltage to get the current. This is how you have to find the current rating, and also finding the speed and torque. How to find the speed and torque? You know torque. Equal to 2 pi nt by 60. 2 pi nt by 60. That means the power into 60 divided by 2 pi. How to calculate the speed? For that, so here if you to calculate the speed, you have to know this equation. The 25 into speed in kilometer per hour and the radius of the wheel. So for assuming 100 kilometer in 2 hours, 100 kilometer in 2 hours, what is the speed? So 100 kilometer by 2, that is kilometer per hour. That means 50. So I put here 50. Speed in kilometer per hour is 50, and radius assume 0.66 kilometer. So that is the radius. From that you can calculate the speed is 200 rpm. So you if you want to do the 100 kilometer in 2 meters 2 hours within 2 hours, if you want to cover 100 kilometer in 2 hours, wheel must be rotated 200 rpm per minute. So this is the calculation, and from that you can calculate the torque, how much torque is produced. And this is the gear. This is for 4-wheeler. How to calculate the gear ratio or 2-wheeler also? Gear ratio calculation. So this is motor teeth, this is the motor speed, and this is wheel teeth. For example, you can take. So from that, this is the equation. You can calculate the wheel speed. So wheel speed is here. So Nm divided by TW. So 1800 rpm here. When motor completes 1 revolution, you can get this one. So that means what you have to calculate the RPM, from that RPM to revolution per second. That means what? This is minute, revolution per minute. If you want to get revolution per second, you have to do by 60. And how much travel? Distance travel per second. So that will give the meter per second. That is velocity. That gives the velocity. So here we calculate 180 RPM. So that is equal to 3 RPM. So 3 into radius pi r. Radius of the wheel and into pi. So that gives the 6.21 meter per second. How to calculate from meter per second to kilometer per hour? So that means you have to do the inverse. Here we did it differently. Here we are converting meter per kilometer per hour into meter per second. Here we are converting meter per second into kilometer. So you have to just multiply into inverse 3.6, you can get the kilometer per hour. This is how you have to calculate the gear ratio. And then, so for example, battery sizing. How to do that? If you have 1.5 volt 1.5 volt battery and 2 amp battery means see in the build you want to drive the motor 24 volt 500 watt. So how many cells it will occur? So that is what here called battery rating calculation or battery capacity sizing. So you know the power 500 watt and you know the voltage here 24 volt. Just calculate the current 20 amp. But what is the cell? What is the one cell current 2 amp? So how many cells you want to get the 20 amps? That is equal to 10 cells you want. But the voltage here is 24 voltage. But here the cell voltage is only 1.5 volt. Then how many cells do you want? You want 16 cells. 24 by 1.5, 16 and 20. So how to do? So you have 20 cells. How to connect the cells in order to get the 20 amp and 24 volt? So that means you want to get 24 volt means from 1.5 volt. What you have to do? You have to do series connection. So you have to connect 16 cells in series to get the 24 volt. Now, if you want to get 20 amp means you have to connect the 10 cells in parallel so that you can get the 20 amp. So this is called battery capacity. And the EV design rating, battery rating. So you can calculate the P equal I plus that just ohms under 20 amp 1 hour. The same 4 hours. If you want 4 hours, then you have to multiply. So multiply into 4 hours. That equal to 8 amp. I hope you understand. This is very, very important. This is called battery sizing. Battery sizing. This is very, very important when you are doing with two-wheeler design or three-wheeler or four-wheeler. So you have to size the battery in this way. You have to know the power and voltage. That's it. You can finish. Here also you see, for example, 1 kilowatt, 40 volts, 20 amp, approximately 20 amp. For 1 hour, it can deliver 20 amp. But if you want, 4 hours, then you have to multiply into 4. That is really. What is the battery rating? 48 volt into 80 ampere hour. You have to say battery rating is in this manner, 8 ampere hour. That is very, very important. How many hours? Actual current is divided by current, then you will get how many hours. Okay. Here, for example, a TVS XL battery range. Here, if you take 48 volt 80 ampere hour battery, but the system is motor TVS XL motor is 1 kilowatt and 48 volt and 20 amp. So how many hours you want? 4 hours you want to do not 200 kilometer. So if you want to travel 200 kilometer, but you have only 20 ampere. So 50 kilometer per hour. So what you have to do? You have to do 4 hours. So for 50 kilometer into 4 hours, 200 kilometers. That means you have to need 4 hours ampere capacity. So 40 into 2, 80 ampere hour. So that's why 80 ampere hour. So battery range in hours. How to calculate the battery range? Just the battery capacity 80 ampere hour divided by the motor current, actual current. Then you count. That 4 hours is equal to the 50 kilometer per hour. So that means this is the range you can achieve. So this is the two-wheeler design, simple electric vehicle design. You don't need to do anything. And also how to charge the battery charging rating. So 1 coulomb means that just 20 ampere hour. So if you apply 24 amp per 1 hour, then it will be charged up to the maximum rating. But if you apply 120 amp, it will be charged 24 amp within 12 minutes. So that is called 5 ampere, 5 coulomb rating. I hope you understand what is the coulomb rating. 1 coulomb rating, that is a charge rate, the rate of change of charging level. 20 ampere you apply means it takes 1 hour to get the 20 amp. But if you apply 120 amp maximum, you can get the 20 ampere within 12 minutes. That is called 5 coulomb rating. Next, so this is Tata. So for total, so I already said it. You have to think about radial force, you have linear force and moving and those things. So assume the example, this is 150 kg. But two-wheeler, as I said already, it is that is 50 kg. But four-wheeler you have to take 150, 150 kg is normal weight, and then other ways. So totally 700 kg. This is Tata Nano. I gathered from EV experts from Tata and TVS. These data are gathered. I collected for this PD, for this FDP, because this FDP is for students and faculty. So we have to give the practical data. That is important. This is the reason I include the design and case study for this in this FDP. Please take note of all those things, and it will be useful for your practical as well as your career also, in your career also. So let us assume that this is area. So this is height and width. So 2.5 meters square, and the weight of the total now is 700 kg, and so 60 kilometer per hour means how much velocity? 16.7 meter per second, and radius of the wheel is 0.3 meters. So you can calculate RPM required. What is the wheel RPM you require? Motor RPM is different from wheel RPM. So that is 527 RPM required, and you have to calculate the forces. That is, you have to think about three forces: lift, drag, and gradient. So these are the three forces you can calculate from velocity, and the coefficient of rolling. This you have to calculate, and the air density is constant. It's not constant. The air density is not constant. You have to calculate coefficient of drag, and this velocity you have to calculate from the RPM speed. So when you do all this calculation, you can get 9.18 kilowatt. That means 9.2 kilowatt. So if you want to do the four-wheeler Tata Nano, how much power rating you require? 10 kilowatt motor is required to travel 60 kilometer per hour. 60 kilometer per hour. So that is the practical. Yes, and it is ongoing also. And further, as I said, so EV power converter design. You want to know, first you have to think about the DC to DC converter, and then you have to think about DC to DC structure. As I said, so battery, this is DC supply. So DC here buck converter. In the usually we used to use if you use 40-volt system, you have to think about buck converter system. If you use 24 volt, then you have to think about. But that one is the buck converter systems. Buck V naught duty cycles. V naught by V duty. So this is the input voltage, output voltage, and what the switching frequency 500 kilohertz, and how to calculate. So this is two parameters we have to think about. Now first, when you close the switch, the inductor is charged. Inductor is storing the energy as well as delivering the output. And when the switch is open, what happened? It can find the path through the diode. That is why it is called a buck. Without input, it gives the output. And that means what? It is less than the source. Less than the. That is why it is called a buck converter. You can calculate the L1. This is very important. L1 and output capacity. These two parameters are very L and C is very important. So L you can calculate using this one. V out is here output voltage is given, and 1 minus D is duty cycle. T on by T out. That is, you can see. And switching frequency is given, and this is the ripple current. You have to calculate with the 30% ripple current. That means what? Output power divided by the input output voltage. Output power is here 120 watt. Output voltage is 180. So into 30% ripple, 0.03 multiply with 0.03, you can get 150. So you can choose 150 and the capacitor also the same. So here we see delta V out means you have to think the output voltage difference and with respect to V out, and 8 times this value, inductor value, and the factor this factor n into switching frequency. So you can follow these two calculating the inductor and the output capacitor. This is also useful for you can store all the values. And then what are the what is the emerging trends and opportunities? As I said before, so government is started supporting the electric vehicles because of green emission. carbon dioxide and carbon monoxide emission is less. That would green environment. So no pollution. That's why government introduced a subsidy on solar renewable energy systems, solar power and also electric vehicle. If you, for example, if you buy solar system for 1 lakh, the 50,000 is given, is 50,000 will be given by the government and 50,000 will be from you. So that is the subsidy. For the government is encouraging the policies not only for renewable energy power and also the electric vehicle system. Not it, they have to do promote the electric vehicle. And many manufacturers, OEM, original equipment manufacturers, and the automotive manufacturer in India are getting benefited from the government. Customers will get benefit soon. And already, they have reduction. The government is already introduced for the renewable energies power manufacturer. 50% off, 50%. And the EV technology development adaptation. That is what I said. You have to think about the what artificial intelligence, Internet of Things, and wireless power transfer on the go, and adaptive systems. So this is we have the opportunity to work out the electric system and research automakers, new emerging startups. Yes, a lot of startups are making the electric vehicle. Nowadays they are getting benefited from the government, and as well as customers also. Customers are nowadays, the Denmark is leading in the electric vehicle, most of it, and also in the renewable energy. Most of the 90% of the power supply is from renewable energy in Denmark, and Germany already done greater than 30% renewable energy. In this status in Germany, I read in 2010. Now they may add more than that. But Denmark is recently added. So, innovation for EV, yes, I explained clearly. Battery technologies and motors. Are you going with BLDC motor or induction motor or multi-phase motor or three-phase motor or single-phase motor? This is, and also the thermal management for systems, motors, and power electronics. Currently you have to see whether are you going to choose silicon carbide systems, silicon carbide switches, or what is the thermal management for those things. So those things are, and battery management system, and fast DC to DC explained many times. And charging infrastructure. Yes, this is because of lack of this charging infrastructure in 1900, it was, the electric vehicle was abandoned. That is what I said in the introduction. And the electric was invented in 1880, and it was up to 1902. It was used by the Chevrolet and many auto manufacturers in Europe. After 1902 to 1925 or 50, it was abandoned because of this charging infrastructure. Now also, not now also, now people and now we have charging infrastructure, but not fast charge. That is giving the opportunity to do more research on the charging infrastructure. That is the present emerging trends opportunities. Charging infrastructure. Battery swapping, including vehicle to grid, vehicle to home. So you just your vehicle from the home, you have to charge the home from the vehicle. So these things are giving more opportunity to do research on these topics. Battery recycling is very, very important because nowadays, as I said, Denmark has 90% is from renewable energy. So they have a lot of energy. And USA has built, California has built the largest. And this one is, they have to think about, they are thinking about how to recycle after 25 years, all the solar panels and the energy sources, systems and batteries. So here I put battery recycling. Recycling is very, very important. This gives huge research opportunities on this battery recycling. Not yet done. These are the present and emerging trends, and giving the opportunity to do more research and think and give opportunity to people and professionals, electrical engineering professionals, to think more to solve these problems like battery recycling, charging infrastructure, and innovation in motors and government policies, producing government policies favorable to the manufacturers and as well as the customers. So here I enter into the last before conclude I thank to a university and the Department of Electronics and Communication as I said in the introduction, Arun Mehta, yes, and also faculty and students of Department of Electronics and Communication. Many thanks to courtesy from because I collected all this information from Tata and TVS because for this PDF FDP I have FDP because this is for students and faculty. So just giving the theory is not enough. We have to give practical data with the calculation. That's why I spend time to thanks to many thanks to TVS Tata employees and Tata. Many thanks for all participants. Please, now I open to question and answers.
Yes, sir. Sir, you can, sir. Like, thank you, sir. Participants, you can post your questions. Yeah, one question in the chat box, Jagdish, sir. Yeah, just above the road floating may help in the parking lot or parking lot and parking.
Yeah, in
Hello.
parking lots, it can be used because we are seeing in several WhatsApp videos that how they maneuver the vehicles so easily for parking and taking overtaking and all that. Overtaking, they will jump over the other car and go. I think for such purposes, this can be used because we are not doing electric flying
Hello?
at great heights.
Yes, sir. Jagdish, sir, your voice is very low. That's why.
I see. Okay, I will just come. We are seeing, now it is okay?
Yes, now somewhat fine, sir.
Yeah, we are seeing in several WhatsApp videos, of course, it is information from WhatsApp University, that for parking and all, people use very effectively the flexibility of the car of levitation. It turns and then it gets parked without even calling the parker who is the neighbor. Okay. And then it sometimes while going, it has a chance to overtake. It will not take it from the sides. It will go on the vehicle and then gets dropped in front of it. So for such purposes also it can be made use of, I think, unless it is called as acrobatics and not allowed by the rule of law. Just thinking. I don't know what Professor has in his mind when he said levitation. The sort of levitation.
Magnetic levitation.
Yeah. You talked of.
I talked about the wireless charging system, like on the go. So magnetic levitation is different from wireless power. It is a kind of wireless power charging, but magnetic levitation is useful for traction systems like moving the train or something. But here, what we are we are going to give the communication not on the go. If suppose what you are tracking is on the in the stationary one, so you no need to work out magnetic levitation. You have to think about the primary coil and the secondary coil of the wireless power transfer system. So one primary coil is in the ground, and the another the receiver is on the vehicle system. But in the magnetic levitation is different. It always communicate with the application. Is not for like the four-wheeler, two-wheeler, this system. That is for traction systems, moving trains and those things.
Okay. Thank you very much.
But on the go is similar to magnetic levitation.
On the go. Okay. Thank you.
Okay, sir. Thank you, sir.
Any other questions?
Yeah,
Participants?
yes, sir. Kiran here. Sir, I should appreciate your energy, sir. Almost 2 hours. You given a lot of information. It was very difficult for at least for me to capture that one. But I noted 2 points, sir. What you mentioned is about this ongoing trends. That is, it was very good. The research and all. I have one question on that one, and you beautifully explained the calculations, which was more of a physics. It was very good. I quickly also cross-checked with the Excel, and it was very good. I have also question on that one. So on this ongoing trends, you talked about some wireless power transfer (WPT). Yeah. So now I would like to know, sir, more on that, because if you see the battery, battery, okay, there are some limitation of the cost, its capacity, and those things that is one of the reason EV is not so accessible. But I would see this wireless power transfer. If is there any much research or any proto happening? Because if that is the case, then battery will be, it is just for a redundant purpose or just to avoid the fluctuation. I would like to know more on that, if there is a proto of that stuff happening.
Yeah, good question. Good question.
And second point, sir, you talked
Yeah,
about
excellent question.
the specifications. I was looking, means before this also, the electric car like Tata Nexon and all the specifications, electric specification, there was very less information they give, especially on the site. In fact, you collected more on that sense, you worked on that one. So I would like to have the Tata Nexon specific, because mechanical stuffs, Newton and those stuffs is available. If you have something like that, it can be also shared, sir. That will be very good.
Sure, sir. So with respect to your question, on the go, people are asking, yes, the ongoing research on the go wireless power transfer system research has been started with my knowledge in 2011. But at the time, these are not boomed like this, so and also you said, if it is on the go, why do we need to think about battery system? Is that your question?
Yeah, exactly, sir. Because because if you say some 10 kilowatt, if you take an example, can you hear me, sir? Hello.
Yeah, I am hearing you clearly, sir. I am hearing you clearly, sir. Please go ahead.
Just for example, let us take one example of 10 kilowatt of the drive or maybe the motor. Obviously, that will be the power expecting. So for that 10 kilowatt to run on the wireless transfer, power transfer, what is that mechanism, or what is? Yeah.
That is, so as I said in the presentation, so it opens the huge research area. Even still, the problem is not yet addressed on the go wireless power transfer. Now people are thinking about the reliable and quickly charging and long range. Only these are the things now people are working on, and some and people, people who are working in a MIT, so Massachusetts Institute of Technology, and like my groups, University of Nottingham and our IITs also, they are now slowly moved to wireless power transfer system on the go, but they are not believing on the wireless power transfer on the go, because even in the wireless power transfer itself, 60% of efficiency is applied. That's what, if you apply 100 watt, so the system can take the second coil, the secondary coil can get only 60%, 60 watt only. So 40% loss. this is what they are thinking about, how to reduce the loss. But on the go, wireless power transfer on the go will not help with respect to efficiency of the system. But if you don't bother about efficiency of the system, then the wireless power transfer on the go is appreciated, and it will come into the consumer side very soon. But not yet. Only New Zealand has introduced just for a testing purpose. Not yet. Only in stationary wireless power transfer system is in the commercial level.
Okay, sir. Fine. Yeah, this is good information.
Enough research has done, but not yet implemented so far, except in well-developed nations. Like China leads in electric vehicle. They also, China also not having the reliable results on the wireless power transfer system.
Yes, sir. Yes, sir. Thank you, sir. Thank you. Like, any other questions, or shall we wind up the sessions? Participants, shall we conclude the sessions? Yeah, I think so. Like, no other questions. We can conclude that. Yes, sir. Thank you, sir. Thank you so much. You have started from that introduction of EV technology, but after that, we learned a lot. Like, what is the working mechanism, how it is working, like internal structure. Also, you have explained, and finally, you have the internal structure, how it is worked, how it can be designed for the complete thing. If you are going for two-wheelers or four-wheelers, the designing point of view have given more and more realistic calculated values, how to calculate and how to identify the efficiency of the battery and everything. You have given an more informative session. It would be here. Thank you, sir. Thank you so much for your nice presentation, sir.
Thank you. I thank once again to KA University and Dr. S. Sir, and the students and the faculty from Department of Electronics and Communication at KA University. Thank you very much.
Sure, sir. We are expecting that future presentation also. Like, thank you, sir. Thank you. We will have the collaborated next level of works also, sir. Thank you, sir.
Yeah, sure. Thank you.
Thank you so much. Thank you, sir.
Okay. Thank you, sir.
Participants, tomorrow we are having a solar power system design using PVC tool. We are having a session 1 and session 2, 2 continuous session, and we are requesting you to join by 10 o'clock. Before to that, 9 o'clock, we are having a formal quiz exam just for the official purpose. That will be shared through your mail. The link will be shared through to your mail. It will be opened by morning 9 o'clock. Thank you, sir. Thank you.